So the final addition to genetics that came from the chromosome theory of inheritance that we're going to talk about are sex-linked traits. So they are related to or linked to the gender of the individual. So these are traits that are carried on the X or the Y chromosome. So females have two X's and males have an X and a Y. So it helps us to see traits that are linked on those chromosomes by looking at pedigrees and different family trees. If, for example, a gene is located on an X chromosome, then the females will have two copies of that particular gene. If it is located on the X, the male will only have one copy of the gene. If a male is XY and a female is XX, males only get one shot at getting the gene. Females get two shots. So that results in some patterns that we can see in our offspring. For example, the gene for color blindness is on the X chromosome. If it's normal vision, it's X with a capital B as a superscript. Just like you would write an exponent in math, that's how you write a sex-linked trait. You always write it with a big X and a little b up top. The gene for color blindness, so if they're normal, they have a big B, but if they're colorblind, they have a little b. In those respects, the big B and the little b, these types of crosses are going to be identical to a dominant, regular law of dominance cross. The difference is you have to cross a male and a female. That's the only way to make babies. So XY and XX will be on the different sides of your Punnett square. So you'll see in the Punnett square I've given you here that XY, so this is Dad on the top of the Punnett square, and XX is Mom on the side of the Punnett square. So Mom has a heterozygous expression of the gene for color blindness. Dad only has one X, so he only got one copy of the gene that was on the X chromosome. And he happened to get a big B. So that would mean that he has normal vision. And Mom has normal vision as well. But she is what we call a carrier for the trait, meaning that she does have the gene for X little b or color blindness. She must have received that from her father or her mother. So when you do your Punnett square, you have to keep track of the X with the B, and you move it just like a unit like you did in all of your other law of dominance Punnett squares. X big B to down, X big B to the side. X big B down, X little b to the side. X big B in from the side, Y from the top. X little b from the side, Y from the top. Now you have two girl potential offspring and two boy potential offspring. So if this couple has children, and let's say they have a boy, their boy has a 50% chance of being colorblind because you're only going to look at this right half of the Punnett square when you're talking about his a male. You're going to look at the left half of the Punnett square when you're talking about females because it's XX. So just be sure that when you do a sex-linked problem that you keep track of the X and the Y, because you're always going to end up with two males, two females as offspring, as potential offspring, and the male is usually going to have a more likely chance of showing the trait than the female, because this female has the trait, but because she has the big B, she doesn't show the trait for color blindness. So for a girl to be colorblind, she would be X little b, X little b. And that's the case for all sex-linked traits that are located on the X chromosome.